All right, let's talk about the order of operations. So we're going to talk about real numbers and the operations on them. Really, we're going to re-establish, maybe not establish, but refresh on and correctly use the order of operations. Okay. In example one, we are looking at lots of coffee. Okay, so this example comes from your book, your Mercer and Sabecki PMGE book. Suppose a venti cup of regular coffee is $2.45. I need to just mention that in your book they talk about how this word must mean really expensive, because this is a lot for a regular coffee, by the way. But really, I need to at least, it just, when I read that phrase in the book about the word venti, immediately I'm like, well, I hope everyone understands that's like a reference to being 20 and an amount of ounces. Okay, so when they are talking about a large coffee and they are calling it a venti, it's really, we have venti. So anyway, there's a regular patron, probably a college student or a nurse, who gets coffee twice a day. Okay, so they're getting a regular coffee 2 times a day. And I put this here because a lot of college students drink coffee. And I'm not going to lie, so do professors. Like, I drink probably half a pot of coffee a day. But I definitely don't purchase it because this is way too expensive. Anyway, how much money does this person spend on coffee in a full year? Well, let's at least just start with a day, because they're doing this twice a day or 2 times a day. So really we're looking at $2.45 added 2 times, or 2 times a day. And that is what, $4.90. 45 cents, 45 cents, 90, and 2 and 2 make 4. Okay. Now, just looking ahead at number 2, there are 2 ways to compute your answer. If you added, rewrite as multiplication. I just kind of said it out loud, so I'm going to rewrite it here. Twice a day means it's happening 2 times a day. So there are 2 of these. So what? $2.45 2 times a day is $4.90 each day. Now, but then it says for a full year. So this $4.90, or just under $5, is happening 365 times. So to get the full year here, I'm thinking, okay, so we are taking this $4.90 and we are, oopsie, I was about ready to write adding it together 365 times, but then I thought, no way. So I'm going to change this to multiplication, and this is being added 365 times. Okay, so I'm going to get my handy white out. I was going to write addition, but then there's no way I'm going to write out that problem 365 times. So I'm going to change that to multiplication. I don't know that the whiteout really helps there. What are you going to do? And then I get my handy dandy calculator. And let's see, $4.90. No, wrong way. Times 365. And it looks like $1,788.50. Okay. $1,788.50 spent on coffee in a year. That's quite a bit, by the way. And then if you added, rewrite as multiplication. If you multiplied, rewrite as addition. Okay, this was our multiplication, and I'm a little bit lazy, but when I see that, I think, okay, well, there's one day spent almost $5. Here's day 2 of the year. Here's day 3 of the year. And here's where I get lazy and I put a ... etc., etc., and so on and so on. By the way, if you know what movie that comes from, I'll be pretty impressed. And then we keep adding these until the last day of the year. So 365 of these. But this is me being lazy. I skipped 361 writings of add $4.90. But what are you going to do? And adding all of those together, you still get $1,788.50. Now, if you want to verify this, by all means, have at it. Add that up on your calculator to check. But I just want to say this. The relationship between multiplication and addition is that multiplication is just a shorthand for repeated addition, okay? So when we think about the relationship between these two, so multiplying is a shorthand or a new symbology, right? For repeated addition. I say symbology, but really it's a new symbology for an indication of the action. So in this case, when we're talking about multiplication and addition, multiplying is the action or a shorthand to represent the action for repeated addition. And I would like to say of the same amount. Okay. And I would also like to mention that here, these are whole numbers. And so if we do repeated addition of the same amount, then we can represent this as multiplication by a whole number. Previously, and if you look at the, there's a fraction review that if this had been a portion, maybe we wouldn't be able to think of it as multiplication this way, but here we are specifically talking about the relationship to addition or the repeated addition. What if spent is represented using a negative value? This should probably be, so I just found a typo. Boop. Okay. How does that change the problem? Well, if we're spending money, we're spending $4.90 each day. Now all of a sudden that is a negative. But we're still doing it 365 times. Okay. But as a total then, this $1,788.50 is still spent. So we are spending, or we are down, $1,788.50 because we're buying coffee. So I just wanted to mention that we could have represented this $4.90 as a negative because it's money going out of our pocket, and so then we'll be down almost $2,000. Complete the following table. Okay, in one day we spend, I'm just going to put dollars for our units up here. We spend $4.90 in 3 days. Okay, now I have my handy calculator. Oopsie, my bad, wrong way. 493 times $14.70. Okay, so $14.70. Oh, 10 of these. Well, 10 $5 would be $50. So 10 days, $4.90 each day, or $4.90 10 times is $49. And 180 times. So here we go. $4.90 spent 180 times, $882. So $882. Got it. And then we already did 365 days. That was $1,788.50. Okay. So this table I feel like was put into the notes because just to mention that really this was a very specific problem, but multiplication as a shorthand really made finding any of these days much quicker than doing this repeated addition problem. And as a matter of fact, I was too lazy to even do this on my calculator because it was 365, typings of this number. So multiplication, it really was critical in making things, computationally proficient. Like we needed efficiency. I mean efficient, not proficient, but efficient. Like we really needed an operation for doing repeated addition, and there you have it. Yeah? Okay. After a few months, it was worth finding a local coffee shop that sells the same amount of coffee for $1.49 instead of $2.45. Okay, here's the deal. I mean, if I were in college, there's no way I would be spending that kind of money on coffee. Okay, let alone the cell phone bill. When I was in college, I was too poor to have a cell phone or a car. But what are you going to do? And a TV. I didn't have a TV either. So all of a sudden, when I even this $1.49, I'm like, just get yourself a coffee pot. I mean, for Pete's sake, if you're going to have coffee twice a day. But let's see. Instead of $2.45, we're talking $1.49 2 times a day. That would be, okay, this is like adding $1.50 twice. That would be $3. So 2 pennies shy of $3, $2.98. Okay, per day. And then this would happen 365 days out of the year. So almost $3 added 365 times. And I compute that on my calculator to be $1,087.70. You should verify that. And you should verify this addition that I did not use my calculator for. And then it says how much money is saved. Okay, so we're really finding the difference between this amount and the $1,788 and what was it, 50 cents. So to find the money saved, we're really starting with $1,788.50, and we are deducting this away because this would have been spent. So $1,087.70. And so the choice between the two, okay, let's see. That definitely needs to go into the calculator for me. We could do it by hand, but why bother? So $700.80. So the difference between these two, or the change, by the way, we called this the actual change in quantities from here to here or from there to there, $700 difference between the two. So there is our amount of savings. That's quite a bit. Now, I'm actually going to go back, even though I know that we're done with this example, because in number 1, I wanted you to see something. I wanted to mention that there was a mismatch of units here. This 365 is really days, and this is money. But I just wanted to show you how these units actually do work out, because this 365... So 365 days, okay, in a whole year. Or I could actually put year here, why not? Times this 490, but that 490 was actually dollars per day. Okay, so when we multiplied this, we found 365 times 490 was $1,788.50, and that was dollars per year. So dollars in a full year. So just wanted to mention this because these units, previously I said label everything. I really do want you to label everything. Like notice how I even labeled all of these with dollar signs just to show what they were really representing. If I had left these off, it would have just looked like that. And a lot of people just don't respond quite as well to not knowing what your numbers are actually. Why are we even computing this? What's the bother here? Okay, but here, so when we see the units, immediately it throws us into the problem like, oh, I see. We care about money. So just a little shout out to units, and that they really are like terms, and we can, or it really was a conversion of terms. Okay. from dollars per day to dollars per year, actually. Okay, let's look at example 2, saving money. You deposit $1,000 into a savings account. I wrote lucky you because it actually took me a very long time in my life to tuck away my own money. Anyway. And your plan is to deposit $100 each month for 20 years. Okay, so you're starting the account with $1,000. You're like, woohoo, I have $1,000. I'm going to tuck it away. And then your plan is to deposit $100 every month for 20 years. How much money will be in the account at the end of 20 years? It looks like I'm going to have to stop this video in order to take care of my kiddo really quick, but I will pick up here in the next video.